Welcome back everyone to another LeetCode problem solving video. Today is day 22 of the journey. We're becoming a software developer here, man. What are you expecting? That was a funny intro, but I'm gonna keep it like that because, we're just getting better here every day. And you cannot be afraid of critics or dislikes. Let me stop this thing. I don't know what my phone wants to record. That's a fail moment, but anyways, welcome back everyone. Thank you so much for being here. I appreciate the time you're about to put on watching this video. Stay to the end. Please watch how we solve this problem. Today we have group anagrams. Nope. Today we have top K elements, frequent elements. We did group anagrams in the video before. Go and check day 21. Today we have top K frequent elements. So that's what we're going to be solving today. This is your first video. Welcome. I'm Enrique Barkley. I'm a business owner transitioning into software development. I have 3 years of experience in software development already as a freelancer using the skills on my business, but now I want to land a job into the tech market, corporate. If your question is, so why are you quitting your business to go and work for someone, which is a very valid question, the answer is very simple for me. And it's, I don't have the field experience. I don't have the corporate experience, which I could perfectly translate into my business. And I don't have that. I had to build that myself from the ground up, and that was a beautiful experience. But also I want to be able to create with a bigger team. When I fell in love with programming, I realized I wanted to put myself out there and actually do the work. So that's the reason I'm doing this. That's the reason you're watching this video. I want to land a job in tech. Yes, the market's hard. Yes, all these things are going on, odds against you, and that's going to be pretty much on anything meaningful in life. If you get struck of luck, good for you, just keep moving forward, but something is going to get complicated at some point and you just have to keep pushing. So that's what we're doing. It doesn't matter where you're from, you can always get to whatever you want. But let's go ahead and jump into the video, you guys. Top K frequent element. We solved this problem before, probably, I don't know, last year. I don't know if the video is already on YouTube. Remember, if you haven't been here before, I've been switching between Grind75 and Neatco websites to see which which list is better for me. I know there's a bunch of lists out there, top smart people making lists for problems and stuff. I really love the one that Neatco put together, but I also wanted to explore other ones. So I was doing Grind75 and whatnot. Today we're going to solve this problem, top K frequent element. Let's just go ahead and jump into the problem description. It's a medium problem, by the way. Let me show you here. You can get this extension if you want. It's a pretty cool extension. You can see the company tags with this extension. It's named LeetCode. What's it called? LeetCode Explain is the name of the extension. Here we go. You can get code complexity, solution code, blah, blah. We don't want to obviously cheat ourselves into solving these problems with that, but it's very helpful to see the companies. And that's the videos I put. That's how I know. I'm not paying for the premium yet, but I'm using the tools to know some other things, okay? So the problem says, given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order, okay? We get one example, says nums, an array of numbers or integers from 1 1 1 2 2 and 3, k equals 2, and we return 1 and 2. Okay, we're returning the most frequent elements out of that array, and then 1, and we return 1. It's kind of tricky because it took me a second there. I was trying to refresh my memory, but it's not asking return the most frequent elements by count, meaning 1 repeats 3 times and 2 repeats twice. It's telling you return the numbers that repeat the most, return the 2 numbers that repeat the most, okay? So k in this question acts as a frequency counter, okay? Return the numbers that repeat twice. It could be 3 times or whatever, but it's counting the frequency. It took me a second there. I've solved this problem before, but I had to refresh there. Let's go ahead and read the constraints. It says the length of the numbers, it's going to be from 10 to the 5, from 1. So very large array, obviously. And the numbers itself, or the integers inside the array, are going to go from anywhere from 10 to the 4 to negative 10 to the 4 to 10 to the 4. So very large numbers, okay? This is going to be, I love when we have follow-ups. Who doesn't love a good follow-up question? That's just throwing another curveball out there for you. That's a baseball reference. I hope everyone knows that, but not everyone plays baseball. K is in the range from 1 to the number of unique elements in the array. That's an interesting one. So K can be to the number of unique elements. Interesting. I would think it would be to all the way up to n minus 1 in terms of like if K would be equal to 3 here, we could always return 1, 2, and 3. So that could be a possibility because there are 3 unique elements in this list or this array, right? So I guess that could be a possibility too. We have to think about that. So K could be equal to the same amount of unique elements here. So we're counting frequency, but we are also, K is going to be equal uniqueness. We'll figure that out. We understand that that's the important part. It is guaranteed that the answer is unique. That's good because obviously that takes away a lot of edge cases we could have to worry about. I'm not saying there's not going to be any, but that takes a lot of it. And the follow-up says your algorithm's time complexity must be better than big O of n log n, where n is the size of the array or array size. So that is another good, it's a follow-up, but it's also a hint because we could always at the time of if we get a time complexity follow-up, and normally on an interview setting you would get this question probably after your first iteration trying to solve the problem, meaning let's say I try to solve this problem and it's on n square, big O of n square. A follow-up could be by the interviewer, could be, can you solve this question in n log n? And that's when you start thinking about different data structures you could use, or maybe a different approach or pattern, whatever. But when here we get the follow-up before we can start basically discarding things from the get-go, meaning I can start thinking about the data structure I could use or the algorithm to solve the problem based on that. But let's move on. 64%, 64.2 acceptance rate, so not too good, not too bad. So yeah, let's go ahead and start thinking about things like examples, okay? And I would love to use a whiteboard app to show like a walkthrough, but I'm gonna try to keep things first. My computer, it's going to kill me if I try to open another app. I have OBS on one side and all these things open, whatever. So yeah, it might be time to change the computer in the future, but we need to get the job first, right? But anyways, I'm going to do the examples right here like we would do in a interview setting. So first thing, let's go ahead and copy our example number 1 here. Great, and let's start thinking how we could approach this. So top K frequent element. So a good thing to know about top K frequent elements is the fact that top K frequency itself can be defined at this point. We should know this, okay? And this is something that I try to highlight as much as possible. We're trying to solve medium questions. We shouldn't be solving this type of questions without some previous knowledge on data structures. And that's step 1. If you're here and you don't know what a heap is and you don't know how to manipulate a hash table or a dictionary in Python, I strongly recommend you do a little bit of review on that first and then jump here, because you need to understand data structures obviously to solve these type of problems. So that's the first thing I recommend, and you get that with time, I have to say, because when I started even this series, if you go and look the first video, I would just really struggle in solving easy problems, and I still do. I'm not a great engineer yet, but that's the road. But anyways, the frequency, we're gonna have to define it with a hash table. It's proven that it's the most efficient way to solve for frequency. Even so, that Python has a frequency counter, name counter. It's already built in Python, so we don't have to build it from scratch. It's good to know to build it from scratch, and it's super easy. All we have to do is create a dictionary, and with that dictionary, start based on the key. If it's not existent in the dictionary, append it with the value, and you use .get with a default value if the dictionary doesn't have the key yet, and so forth. That's another topic. But anyways, we should know to use to create that, because we're going to count frequencies, and the way we're going to do that is like this. We're going to have a dictionary, right? And the dictionary basically is going to count frequencies, and I'm thinking about using counter on Python. And what counter is going to do is create a dictionary that's going to have key and values, obviously. The key in the dictionary, it's going to be the number we are iterating over, right? We're going to iterate over the array of numbers right here, our input array, and the counter is going to work like this. So 1 is the first number we see. We go ahead and add it as the key of our dictionary, and then the iteration is going to go 2 and 3. So by the frequency of that number, we would have that as the value in the dictionary, okay? So it would be 1 and 3. Now, notice that we don't have to do this manually. We could, it's good to know that, but we're going to use counter in Python, okay? We can use the counter data structure, which basically, or function, it basically creates that counting or frequency dictionary for us. So at the end of that iteration of the counter, we're going to have the following data structure. So this is the end result of counter. So basically counter went and iterated over the whole input array and counted the times that that number repeated itself in that dictionary, okay? Or in that array. So that is the first part of our problem. Now that we have the frequency, the next step we need to do is basically retrieve the elements that have the highest frequency, right? So notice, first we count the frequency of the elements, okay? First we get the frequency of the elements. We have that right here with counter. The next thing we could do is retrieve the k most elements, right? Because now we know that 1 and 2 are the elements with most frequency, right? With the highest frequency. So in that case, I would say there is a data structure we could use here instead of going, because remember, k could be even equal to the amount of numbers we have in the array, okay? So there is a data structure we could use for returning top k frequent elements. And that data structure, it's called a heap. In Python, by default, we're going to have a min heap or a minimum heap, which the heap is basically going to be structured in the following way. And let me pop up on screen. I'm going to show right now how a min heap looks. This is how the min heap looks. And as we can see here, the min heap is basically the root node, the node on top. It's going to be always less than each of its children's, okay? Also, a good quality of a min heap is that it's always left a balance. So we could see here in that image that the heap is balanced to the left, okay? The nodes on the left side basically have the children's. You can see that the nodes in the right child not necessarily could have a children. In the case that, as we can see in the image, in the case that the ones that have it, then it's not a heap, okay? But the min heap contains the main point of the min heap is that contains the parent node as the minimum value of the entire heap. You see the root node is the smaller one, and then it goes down, and every parent node is smaller than its children. Okay, good. Now that aside, now that we know how a heap looks, think about finding the k most frequent element. Imagine that we're going to arrange these as a heap. Meaning, if this is a min heap, then 3 would be on the top of the heap because it's going to be the root of the heap, right? Where the smaller frequency of numbers, okay? 2 would be the left child of that heap, and then 1 would be the right child of that heap. The order really doesn't matter here on heap because we're maintaining a sorted order, right? As we can see from minimum to maximum. But also notice how the left side doesn't really have to be sorted with the right side. Having the smaller node on the left side really doesn't matter here. All we want to is be able to iterate and remove the numbers with the less frequency, because that's what we're looking for here, okay? So that's good to know. That's good to have refresh in your mind. In Python, we could use a heap queue data structure. It's part of the collections model. A point I want to make here is depending on the language you're using on LeetCode, you can see here that for Python, we have most libraries already imported automatically for convenience. So collections is the one that we're going to basically be using with the counter and the heap queue. We don't have to import them. We can basically just define the function and start using it. But it's good to know that because I've seen some people using imports here, and it's, I guess it's a good practice to import things up here. I've done it previously too, because obviously you're not gonna have these libraries available for you on an interview, so you could get used to that. But it's good to know that you really don't need to do that here in LeetCode specifically. But the next step is basically knowing that a heap is going to help us return the frequency of each value here. Okay, so far we have that we're going to count the numbers in each, or the frequency of each element in the hash map. Then we're going to iterate over the frequency map, adding each element along with its frequency, like we're doing right here. Okay, and then we're going to create a heap and maintain the size of the heap is smaller or equal to our k most element, because we really need, for our example here, and I guess I could have put that here, k is going to be equal to 2, right? So we really just need the 2 most frequent elements out of our array here. So our heap honestly only needs to be size 2, which helps on the time complexity here, because our heap structure doesn't have to contain all the elements of the array. If k would be equal to 3, then potentially in the worst case it could be, but really in the best case or average, because k is not always going to be equal to the amount of numbers here, it could be up to the unique elements in the array, but not always. So for the best case, we can always keep that complexity, time complexity, lower as we store the size of the heap equal as k. So basically we can do a check and say if the size of the heap is greater than k, then we can pop elements. And that's another good thing about heaps, is that we are going to be able to pop elements from the heap, and it's not going to mess up our structure, because the heap is going to contain the top element as the minimum. So all we have to do really is pop that element from the top, and the heap queue on Python is going to take care of the sift up that has to happen. Priority queues, which is basically the underlying name for heap queue in this case, it's basically a process that's going to take, it's going to rearrange and keep the heap in its order. So for Python we have a min heap, and C++ we use a max heap by default. Okay, and there are ways to manipulate these data structures, but the main point is that we could return the elements from this heap by popping the root of that heap, and we're going to have the 2 children nodes with the max value. Okay, so perfect. Let's go ahead and start working on our code. I think we're pretty clear here, but basically we're going to keep the heap at the size k, and after we process all the elements, we're going to be left with the elements of the heap that we have to return. So we're going to convert that heap into a list, and then we will proceed. So the first step would be to initialize our counter, or frequency counter. So once we initialize our frequency counter using the counter function from Python, we're passing our nums array, and basically that frequency is going to create a dictionary as the following based on the input array. Okay, and the next step is that we're going to initialize our heap. The heap can be represented in an array in Python. So basically, since we're going to be having a min heap, we're going to simply initialize our min heap like that, and we have the data structures we need to start working on the code. So the first thing we're going to do is obviously iterate over our dictionary and start adding the frequencies that we counted to that heap. So the way we're going to do that is basically say, remember how the dictionary is keeping the order of our numbers. So the first number is going to be containing the number itself that we're counting, and the value of that key is going to contain the frequency. So we're going to unpack that, basically saying for number and frequency in our frequency items, let's go ahead and start working with that. So what do we need to do here? Well, let's go and add every number to the heap. A good thing we could do here is, well, number one, knowing that the heap in Python is going to take 2 positional arguments, and these arguments are going to contain the heap we're going to pass the structure to. So this one right here, the heap we just created, and the second argument could be anything, but preferably is something that we could compare. So before I get there, I'm declaring my heap queue structure. Remember, this is already imported from collections model, and then I'm pushing to my heap the following, and that's where the tuple is going to come in handy. But the first argument, as I mentioned, is going to be that mean heap, we just define it, right? So we're basically saying push into that mean heap the following tuple. A tuple in Python we define between parentheses, and what we want inside that tuple is basically the frequency and also the number. But notice how we basically swap the elements here, because we're iterating the way that the dictionary has, and it's the number we're counting and the frequency. But the tuple has a very good quality or characteristic, and that's the reason we're using it. And that's kind of like what I want to explain, is that in the tuple, the frequency, the first element of that tuple, is going to always compare to the second element. Meaning, if I have, and I'm gonna make a quick parenthesis just to explain that for the people that don't know this. So let's say we have these two tuples right here. We have 1 and 10 and 2 and 0. Comparing to 1 and 10 is going to be smaller than 2 and 0. Well, why is that? Because tuples compares the first element of both tuples, right? So even though we have a 10 here, that 10 doesn't count technically, because the comparison, it's being done between 1 and 2, or basically the first two elements. So that's why we're making frequency being our first element in this tuple we're passing into our mean heap. So as we can see, that's the reason we're using a tuple here, okay? We have the number and the frequency we get from the dictionary, but at the time to add it in our heap, we want that frequency to be the first element, because at the time of comparison we want that to go to the top of the tree, okay, or the heap. We want that smaller number to go ahead and bubble up, okay, and this is another term for the heap, okay. So we're working on that. We're good to this point. We're creating the heap queue here. We're using heap push, that it automatically is going to take care of adding that to the top of the heap, because it's maintaining a minimum heap. Okay, and that's just a characteristic of heap queue. It's a data structure for Python that we should be familiar with. Same thing with heap push, okay? So we're adding these two elements to the mean heap. Now, and this is just for example, I'm going to delete that so I don't confuse you guys. Now, I want to check if my heap ever exceeds the amount of elements I need. For this case, I only need 2 elements. So I don't need a heap of size 4. Because we're really needing to extract, let's say, or to return 2 elements out of that heap, okay? So how do we do that? Basically, we are going to drop a condition here. So if the size of that mean heap, I mean, in Python, that's pretty straightforward. If the length of mean heap, it's greater than our element k, right? Then we're going to use the heap function again to basically take care of removing that extra element. Naturally, as we mentioned, is going to remove the element on top of the heap, which is the minimum number. In this case, it's going to be 3, because it's the element with the less frequency. And since we added our elements sorted by frequency in this case, that's what the heap is going to remove. So again, we use our heap queue data structure, and we basically say heap pop. Okay, so what is the heap pop actually going to remove? Well, like in a normal array, where the pop function in an array in Python would remove the last element, right, in the array. Well, result that the case for the mean heap is going to remove the top element, okay? So basically the minimum element in this case will be 3, because 3 is a number with the smaller or less frequency, right? We simply just have to pass here mean heap. So basically at this point, really, we're adding our elements to the heap sorted by frequency. We're making sure the heap stays under k elements, because that's what we need to return. So at this point, really, all we need to do is basically return or subtract, I would say, the k most elements, okay? We could do that in different ways. Straightforward in Python, we could use a list comprehension. So we're basically going to say here, return, and I'm going to create a list comprehension here that is going to be sorted. And this is very important. We don't need to return the frequency. We already have the most frequent elements, okay? So what do we need? Well, we need the number, because that's what the problem is asking here for, right? It's asking for the 2 elements, or the k frequent elements, but we don't need their frequency. We just need the numbers that are more frequent. Notice how they return in an array. That's why we're creating a list comprehension here, because in Python, or array comprehension. That's not really the name in Python, but basically we're creating an array on the go, and we're gonna sort that by the characteristics of the list comprehension here by the last number, which is our element right here. And the way to do that is basically we're gonna say pair, and I'm gonna name that pair just to have something to understand here, because we have a pair of tuples, okay? And this is what we're sorting. This is where we are subtracting from that heap. We would do that like this in Python. The first element is what I need for pair in my min heap, right? That's basically what I need. And that's pretty much it. We are creating an array here, subtracting the last element of that pair. We have this 2 right here, okay? And then we're saying return that on a list. And I think we're pretty much done here. So let's do a last walkthrough over our code to make sure we're not overlooking anything. So we're initiating our frequency counter here with the counter function from Python. We're passing our nums array, and that's going to create a dictionary like the following, counting the number and the amount of time that number appears, or its frequency. Then we're initiating a min heap, and the min heap, we can basically initialize it as an array, right? Then we iterate over our elements in that dictionary of frequency. And remember, to iterate over a dictionary, we want to call items because we want to extract the number and its frequency. Then we pass that to our heap. Again, the heap queue in Python is going to take care of the min heap. Okay, it's basically going to organize or sort for us the elements we pass. The heap push function is going to take 2 arguments. Number 1 argument, or the first argument, is the heap or the data structure we're going to be adding elements to. The second one could be pretty much anything, but it's used in Python to pass a tuple, because in the tuple, as I mentioned, we could compare the frequency of an element or the priority of an element with the first argument right here, and then the element itself. Then we check that the heap stays under the size of k, because we don't need to have a larger heap if at the end of the day we just have to return k elements, okay? So we remove any extra element. In this case will be 3, because it's the smaller one. It sits at the root of that heap. We pass our heap here, and then basically we just have to subtract our top k element. And we could do that by adding it to a, let's say we could do it like this, top k element, and we would just do the same iteration with it here, add it to top k element, and at the end just return top k element, okay? That's just a way to basically hold top k element in case you would need it for something else in bigger, more important function. But in this case, just returning the actual list comprehension, we're safe, okay? I'm gonna go ahead and submit my code. We'll see if we hit any walls, and I think we're good. Perfect. 3 milliseconds. Awesome. Guys, we've been sitting on top of the leaderboard for 2 days now. Nice. Okay, I know this is not relevant, but we have to have some fun with it. But yeah, great. Okay, yeah, so make sure this is something you understand before solving the problem. Heaps are gonna be big part of solving k problems. Any top k or find k or frequency of k is going to be very attached to a heap data structure for the qualities of a heap, as we mentioned before. Let's talk about time complexity and the space complexity. I'm going to analyze here just to make sure n log k, and that makes perfect sense, okay? And I'll explain that. So remember down here, we have an n log n follow-up question that says, where complexity have to be better than that? We have n log k, which is better than n log n because we're iterating over the whole array here. That's going to be big O of n. As we add every number of that array or every integer of that array into our dictionary, that's big O of n naturally. Now, where things can get real greedy is when we're pushing elements into that heap. But remember here, we're keeping the height or the size of the heap up to k, okay? So every time we push an element here, we also make sure we keep the height or the size of the heap. I keep saying the height, but it's the size. It could also technically be the height because we're in a tree data structure and we're keeping certain height. But to be more formal for the problem we're trying to solve, the size of the heap, it's always sustained at k. So there's never going to be over k elements in our heap. So I think we did pretty good. I think our approach would be very solid. There are thousands of ways to solve this problem. I feel very comfortable with this one right here. Naturally, using Python data structures, it's a good way to put them in practice, because that's what you would do in a real scenario. Now, keep in mind that using counter or heap, I mean, I think with the heap you're pretty safe, because an interviewer would let you use the heap data structure in Python. Now, the counter is something that, again, it's good to know how to implement it from scratch, because it's basically a dictionary counting and adding elements. The first element is going to be the most difficult one. You just got to make sure that you have a default element before, or you're going to get a key error. But besides that, I think you're pretty safe with the counter function for Python, because it's standard. So nice. I think we're pretty much done, you guys. I really appreciate the time. I really appreciate you watching these videos. Any view, any like, any comment, just let me know. If you're on the other side, if you're in struggle, if you're already working for a company doing this, I would like to interact with more people out there. I would like to put my story out there. I try to bring value with this type of videos, but also I like to look back to these videos and see how better I'm getting. So yeah, I appreciate you guys watching. Subscribe and like this video if you enjoy the content here. I really appreciate your support. Thanks so much. I'll see you guys in the next one. Day 23 coming up.